What if I told you that scientists at CERN have actually discovered a way to tear open a portal to another dimension? In July 2022, something extraordinary happened at the world's most powerful particle accelerator that has physicists both excited and terrified. Today, I'm going to reveal exactly what CERN discovered, how they potentially opened a gateway to parallel universes, and why some of the world's brightest minds are warning this could either revolutionize everything we know about reality or destroy our universe entirely. CERN, the European Organization for Nuclear Research, has been pushing the boundaries of physics for decades. But their latest experiments with the Large Hadron Collider have taken us into uncharted territory that sounds like it's straight out of a movie. To understand how scientists might have opened a portal to another dimension, we first need to grasp the incredible power of the machine that made it possible. Picture this: a massive underground ring stretching 27 kilometers in circumference, buried beneath the Swiss-French border. The LHC weighs over 7,000 tons and brings together more than 10,000 scientists from 85 countries. The sheer scale of this project is mind-boggling, but it's the energy levels they're working with that truly set it apart from anything else on Earth. The LHC is so powerful that scientists have been able to recreate the conditions that existed just 1/billionth of a second after the Big Bang. They're recreating the birth of the universe in a controlled environment. As one CERN scientist explained, the goal is to recreate conditions that existed some 10 microseconds after the Big Bang, when all matter in the universe was in the form of an incredibly hot soup of quarks and gluons. Inside that 27-kilometer tunnel, superconducting magnets create a pathway for particles to travel at speeds approaching the speed of light. Two beams of particles, usually protons, are fired in opposite directions around the ring. One beam travels clockwise while the other goes counterclockwise. These particles are accelerated to 99.9999999% the speed of light before being directed toward each other in a controlled air collision. When these particles collide at such incredible energies, they break apart into even smaller components, including quarks and gluons. These subatomic particles are extremely unstable and decay within fractions of a second. But in those brief moments, detectors inside the collider capture data that reveals the fundamental building blocks of reality itself. Since 2008, CERN has been conducting increasingly powerful experiments with the LHC. But in July 2022, they attempted their most ambitious experiment yet. Officially, they claimed they were studying the Higgs boson and particle interactions. However, rumors began circulating that they were attempting something far more extraordinary, opening a portal to an alternate universe. Before we dive into the 2022 discoveries, we need to examine a mysterious incident that occurred 6 years earlier, which many believe was the first sign that CERN was experimenting with interdimensional portals. On June 16, 2016, CERN launched a project to accelerate charged particles to energy levels never reached before. 10 days later, photographer Christoph Suarez captured striking photographs of the skies over the facility. These were not ordinary clouds. The images revealed unnatural formations and unusual electrical activity above the particle accelerator. The photos spread rapidly online, fueling debate over whether CERN had opened a portal in the sky. The timing raised serious questions. CERN initiated its most powerful experiment ever, and within days, bizarre atmospheric phenomena appeared directly overhead. This led many to worry that the experiments could either destroy our universe or uncover parallel worlds existing alongside our own. Concerns were heightened by the fact that the Large Hadron Collider had already created microscopic black holes during particle collisions. Although these black holes vanished almost instantly, their existence suggested the experiments were probing dimensions and forces far beyond conventional physics. Physicist Stephen Hawking, one of the most respected scientific minds in history, issued repeated warnings about CERN's work. He famously bet physicist Gordon Kane $100 that the Higgs boson, or God particle, would not be discovered. When CERN confirmed its discovery in 2012, Hawking did not celebrate. Instead, he intensified his caution. In his book Starmus, Hawking explained that the Higgs potential could become unstable at energy levels above 100 billion gigaelectron volts. He warned that the formation of small black holes at such energies might expand uncontrollably, potentially consuming the universe from within. British astronomer Sir Martin Rees shared similar fears, warning that the collider might unleash strange, unstable matter capable of triggering a catastrophic vacuum decay, a collapse of time and space itself. Hawking's most unsettling point was that such a disaster, however unlikely, could occur without warning. Even if improbable, the possibility of the Higgs field destabilizing at extreme energies was too dangerous to dismiss. Now let's dive into the actual science that makes interdimensional portals theoretically possible. The key to understanding this lies in two of the most mysterious aspects of our universe, the Higgs boson and dark matter. In 2012, CERN achieved what many consider the most important scientific discovery of the 21st century when it confirmed the existence of the Higgs boson. This particle, often called the God particle, is believed to be responsible for giving all other particles their mass. The discovery validated the standard model of particle physics and provided crucial insights into how the universe formed immediately after the Big Bang. Now that scientists have identified the Higgs boson, they've set their sights on an even more elusive target that could be the key to interdimensional travel: dark matter and dark energy. Everything we can see, touch, and measure in our universe, from planets and stars to galaxies and nebulae, makes up less than 5% of all existence. The remaining 95% consists of dark matter and dark energy, invisible substances that we can only detect through their gravitational effects on visible matter. This is where the portal theory becomes scientifically plausible. Astrophysicist Zhen Liu at the University of Minnesota believes that the Higgs boson could serve as a bridge between our visible world and what he calls the dark world. According to Liu, the Higgs boson might function as a portal between dimensions, allowing particles to transition between our reality and parallel dimensions we cannot normally access. The theory suggests that there are dark particles that only interact with normal matter on extremely rare occasions. These particles could potentially be caught up in the high-energy proton collisions that the Large Hadron Collider creates continuously. If scientists can detect the decay or transitions of these dark particles using quantum mechanical coupling, they might be able to directly observe and even create particles from other dimensions. Liu expressed his excitement about the possibilities, stating that if we could master control over both luminous matter and dark matter, the implications would be breathtaking and world-changing. Enjoyed the video? Before we continue, don't forget to ring the bell, share it with your friends, and hit that subscribe button if you haven't yet. It truly helps me out, and I promise to bring you even more awesome content. Now we come to the most shocking discovery in CERN's history. What happened in July 2022 has left scientists scrambling to understand the implications, and it might prove that interdimensional portals are not just theoretical anymore. On July 5, 2022, CERN fired up the Large Hadron Collider for what they called Run 3, operating at the highest energy levels ever achieved. The official announcement stated they had collisions at an unprecedented 13.6 tera-electron volts, opening what they described as a new era of exploration. But what they discovered in those collisions was far more extraordinary than anyone expected. The LHC detected 3 completely new exotic particles that had never been observed before. These were not just variations of known particles. We are talking about a new kind of pentaquark in the first pair of tetraquarks, including a completely novel tetraquark that defied existing models of particle physics. With these discoveries, the LHC has now identified a total of 70 new hadrons, but these 3 were different. They appeared to exhibit properties that suggested they might originate from dimensions beyond our own. 2 days later, on July 7th, something unprecedented happened to Earth itself. A massive crack appeared in our planet's magnetic field, and this was not some minor disturbance that lasted a few minutes. This crack remained open for 14 continuous hours, allowing solar winds to stream directly through the opening and causing intense geomagnetic storms across the globe. The timing cannot be ignored. CERN conducted its most powerful experiment ever on July 5th, discovering particles that seemed to come from other dimensions. 2 days later, Earth's protective magnetic field develops a massive crack that stays open for over half a day. Officially, scientists attributed this magnetic field disruption to something called a co-rotating interaction region from the Sun. But many researchers believe the timing suggests a direct connection to CERN's experiments. If CERN's particle collisions can affect Earth's magnetic field, they are dealing with forces that operate on a planetary scale. The magnetic field crack allowed solar radiation to penetrate our atmosphere in ways that created spectacular auroras, but it also raised terrifying questions about what other effects these experiments might be having on our reality. Some physicists have theorized that the exotic particles discovered on July 5th might have created a temporary bridge between dimensions, and the magnetic field disruption was evidence of our reality being pulled toward or connected with a parallel universe. The 14-hour duration of the magnetic crack corresponds almost exactly to the time it would take for the exotic particles to fully decay and break their interdimensional connection. After the July 2022 incidents, CERN made the decision to temporarily shut down the Large Hadron Collider for major upgrades. But these were not routine maintenance improvements. The modifications they are implementing will make the collider more powerful than ever before, capable of energies that could potentially tear permanent holes in the fabric of space-time itself. The Large Hadron Collider was offline for 2 years specifically to prepare for what scientists are calling the most ambitious phase of particle physics research in human history. When it reopened in April 2022, it represented the most advanced version of the machine ever constructed. A CERN support manager explained that Run 3 is exciting not just because it provides more data at higher collision energies, but because the detector systems are now the best they have ever been. The trap, as they put it, is now set to catch particles from other dimensions at any moment. Leon Tao Wang, a professor at the Enrico Fermi Institute and the Kavli Institute for Cosmological Physics at the University of Chicago, stated that if interdimensional particles exist, they just need to find the right way to detect them. Usually, he explained, the key is asking the right questions and knowing what to look for. But CERN's ambitions extend far beyond the current Large Hadron Collider capabilities. They are already planning upgrades that will increase both collision energy and luminosity while implementing dramatically improved detection systems. The luminosity upgrade began in 2018 and is scheduled for completion in 2027. After these modifications, the particle collider will be capable of visualizing rare processes that occur at the boundary between dimensions. Looking even further into the future, CERN is developing what they call the next generation of Higgs factories. These facilities will be entirely focused on examining the possibilities centered around what they are calling the Higgs Gateway. The International Linear Collider under consideration in Japan, the Compact Linear Collider at CERN are 2 linear Higgs factories designed specifically for interdimensional research. Meanwhile, China is developing a particle accelerator that will be 5 times more powerful than the current Large Hadron Collider. The race between Europe and China to unlock the secrets of interdimensional travel has become one of the most significant scientific competitions in human history. The question is not whether we will discover how to open stable portals to other dimensions, but rather who will achieve this breakthrough first. If one country becomes the first to open a stable portal to another dimension, do you think that knowledge should be shared with the entire world or kept under strict national control? Let us know in the comments below. As CERN's experiments have grown more powerful, they have drawn both scientific interest and conspiracy theories. While many of these claims are baseless, others raise questions about what CERN might be pursuing beyond its stated research goals. One prominent voice is Max Lowen, a teenage quantum physics prodigy often described as one of the brightest young minds alive. Lowen theorizes that CERN may have destroyed our original universe during its experiments, shifting humanity into a parallel timeline without anyone realizing it. His concept, rooted in quantum mechanics, suggests that the extreme forces during particle collisions push particles in consciousness between dimensions, creating an infinite loop. He points to CERN's discovery of 3 previously unknown subatomic particles in July 2022 as supporting evidence. If true, Lowen's idea implies that every person on Earth experienced a dimensional shift in 2022 but retained intact memories, making the change undetectable. Some researchers extend this notion further, speculating that CERN may have opened portals allowing entities or substances from other dimensions to cross into ours. They argue that exotic particles observed in experiments could be indirect evidence of such contact. More controversial are claims that CERN's experiments have non-scientific motives. In 2016, footage surfaced appearing to show individuals in black robes conducting a ritualistic at CERN's grounds. The video depicted what looked like an occult ceremony ending with a staged attack on a woman. CERN dismissed it as an unauthorized prank by staff, but critics questioned how such an elaborate act could occur at one of the most secure scientific facilities in the world. Fueling these suspicions is CERN's statue of the Hindu deity Shiva, known as the Destroyer of Worlds, displayed prominently at its Geneva headquarters, near where the alleged video was filmed. CERN describes the statue as a symbolic gift from India celebrating the cosmic dance of creation and destruction that mirrors their research, though skeptics interpret it as further evidence of hidden motives. While no evidence confirms these theories, they highlight growing public unease over the scope of CERN's work and its potential consequences for reality itself. The potential benefits and dangers of CERN's interdimensional research represent perhaps the greatest risk-reward scenario in human history. On one hand, successfully opening stable portals to other dimensions could revolutionize our understanding of physics, provide access to unlimited energy sources, and potentially allow us to explore parallel versions of our universe. Physicist Brian Cox, who gave a famous TEDx talk about CERN's work in 2008, explained that the goal of particle physics is to understand what everything is made of and how the fundamental forces hold reality together. Through the LHC, scientists hope to unlock secrets about antimatter, dark matter, and the basic structure of existence itself. The ability to access other dimensions could provide solutions to some of humanity's greatest challenges. Imagine having access to resources from parallel Earths, or being able to study alternate versions of historical events to better understand our timeline. The scientific knowledge gained from interdimensional contact could accelerate human technological development by centuries or even millennia. But the potential dangers are equally staggering. Stephen Hawking's warnings about vacuum decay and the destabilization of the Higgs field represent existential threats to our entire universe. If CERN's experiments trigger a cascade effect that causes space-time itself to collapse, there would be no escape and no warning. The destruction would spread at the speed of light, erasing everything in its path. The creation of stable black holes presents another catastrophic risk. While the microscopic black holes currently produced by the LHC evaporate almost instantly, more powerful experiments might create larger, more persistent black holes that could begin consuming matter and growing exponentially. Even a black hole the size of a marble would have enough gravitational force to eventually consume the entire Earth. There's also the unknown factor of what might come through an interdimensional portal from the other side. If parallel universes contain hostile entities or dangerous forms of matter that don't exist in our reality, opening a portal could expose our universe to threats we're completely unprepared to handle. Perhaps most unsettling is the possibility that we might not even realize when something goes wrong. If Lowen's theory about timeline shifts is correct, we could experience multiple reality changes without retaining any memory of our original existence. We might already be living in a damaged or artificial version of our universe, completely unaware that our true reality was destroyed years ago. Humanity may be on the verge of its most significant scientific breakthrough, opening stable portals to other dimensions. The question is no longer if CERN can do it, but what we will find when they succeed, and whether we are ready for the consequences. Clues already suggest CERN's experiments have achieved more than publicly admitted. Unusual cloud formations over the facility in 2016, the discovery of exotic particles in July 2022, and a simultaneous crack in Earth's magnetic field point to experiments that could be altering reality itself. These newly discovered particles may produce gravitational waves strong enough for future detectors to trace their origins to other dimensions, offering a way to map parallel universes and even communicate across them. The Large Hadron Collider's current run continues through 2024. Afterward, it will undergo upgrades and reopen in 2028 as the high-luminosity Large Hadron Collider, vastly more powerful and capable of creating portals that remain open for extended periods. Meanwhile, Japan and CERN are developing linear Higgs factories, while China is building circular accelerators projected to be 5 times more powerful than CERN's current collider, intensifying a global race for interdimensional access. Recent research in the European physical journal C proposes that particles may travel into a 5th dimension, linking visible matter with dark matter. These findings could explain dark matter's nature and enable revolutionary applications solving energy crises, enabling dimensional travel, and even transferring consciousness between parallel versions of ourselves. Yet these breakthroughs carry enormous risks. If portals can be opened by us, they might already be used by others. Exotic particles detected at CERN could be evidence of entities from alternate realities studying or contacting us. Despite extensive safety measures, Stephen Hawking warned that catastrophic events could unfold too quickly to be contained. This race is not merely scientific, it is philosophical and geopolitical. The first nation to master portal technology could reshape global power and redefine humanity's place in the cosmos. Whether this leads to an era of discovery or catastrophic collapse will depend on how we handle powers unlike any we have known. What do you think about the possibility of interdimensional portals becoming a reality? Are we ready as a species to handle contact with parallel universes, or are we rushing toward discoveries that we're not prepared to control? And perhaps most importantly, if these portals do open successfully, who or what do you think we'll encounter on the other side? As CERN continues pushing the boundaries of physics and reality itself, we may soon discover that the universe is far stranger and more interconnected than we ever imagined. If you enjoyed today's video, please give it a like and don't forget to subscribe to the channel. Your support means a lot to us. Thank you so much for watching, and we'll see you in the next video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.